Hmm. Alrighty, so this is a presentation going over the project plan for the crisis management system software, which was developed by Shelby Bischoff, the project manager. So some background on this software. The crisis management system software is a software that will be a central data manager and will receive social media reports of fatal events. The social media reports will come from people's stories or posts on their social media pages. And then the software will categorize these events into critical and non-critical events and send this information to the first responders data center for them to respond to these events. This will be a helpful tool for first responders to react quicker to life-threatening events, natural or man-made, and therefore save lives that they may not have saved in time without the software. So going into the goals and objectives of this project, the key goals are to analyze the social media reports and determine how critical the events are that are happening at the moment. The next goal is to organize and file the reports to critical and non-critical events. The next goal is to deliver this social media report analysis to the first responders data center. Then to keep the software system within the budget that the customer has given the project team. And then the next goal is the software system meets all requirements that are discussed upon and agreed upon by the customer and the engineers. The main objective of this software is to deliver the results or organized files to the first responders data center within a minute of the social media report. This is the main measurable goal, like right now, objective that we want to keep it within a minute, other than the budget. So some context of this software. The crisis management system will deliver organized files of social media reports that will help the first responders. The system will also provide a location and time of the life-threatening event. And the social media reports will be coming from cell phones that are connected to the cellular networks. The social media that will be used includes Snapchat, Instagram, Facebook, and Twitter. So some major constraints for this project. One is the client has stipulated a cap of $550,000. The next constraint is that the software must be on the market and being used within 2 years. So that's our time constraint. Some other technical constraints, the CMS software will only have access to social media stories or posts and will not have access to people's account information for privacy reasons. So we don't want any lawsuits for this software based on privacy and that type of stuff. And then another constraint, the CMS software will have access to most, if not all, of the cellular networks. So we'll get into that when we talk about the risks, because that's kind of like mitigating some risks that come up later. So some project estimates. These are the salary estimates for the workers for this project. So the first is a senior software engineer who will be the technical lead and will also have responsibilities of programming for this software. There's going to be 5 total members, so 2 database analysts. So they will be doing database management. And then the other 2 will be program analysts too. So they will do data analyst and will also do some programming for the software. So based on these numbers in this table, the average labor rate based on the 5 members: 1 senior software engineer, 2 database analysts, and 2 programmer analysts, will come out to $6,001 per month. And then the burden labor rate, which includes benefits, etc., within working for the company, will come out to be $888,822 per month. Now going into the lines of code, the estimated lines of code for this software. So the system controller is estimated to have 500 lines of code. Then the crisis data receiver is estimated to have 250 lines of code. The crisis data analyzer, which is like going to be the main part of this software, like analyzing and categorizing the events, making sure that they're life-threatening, etc., will have 5,000 lines of code. The crisis data filer will have 500 lines of code. And then the crisis data sender to the first responders will have 250, with a total of 6,500. So then this will go into the Kokomo estimator, and we'll go over the factors that were decided for this estimation. So the first category, the product attributes, the required reliability was rated very high due to the system will be helpful to saving people's lives, but people may try to blame the system if the system fails in a crisis. So if the system is not working and first responders don't get to somebody who's in a life-threatening situation in time and the person dies, there may be lawsuits because our software broke down, something to blame, like that type of stuff. So we rated that as very high. And the database size, very high. We're gonna be collecting data from millions of people using their cellular, like millions of people use social media, and they'll be posting on their social media accounts. So we'll be going through those. Product complexity, nominal, assuming nominal, control complexity, and computational operations. Then going into computer attributes, the execution time constraint, extra high. It'll be continuously running the software because life-threatening events can happen at any time. And then the main storage constraint, extra high, 95% use of available storage. Again, there's going to be millions of people using social media, and it'll be going through all that data, and it will be using a lot of the storage for this software. And then the platform volatility, rated that as nominal, assume not many major changes within the year and some minor ones. Computer turnaround time, low. We would like it to be interactive, no delay, ideally, but at least under a minute. Then going into the personnel attributes, analyst capability, high. Assume programmers for this team overall are in the 75th percentile, considering ability, efficiency, thoroughness. So like based on that, the description for analyst capability, we rated that as high. The applications experience, we rated that as nominal, assuming team overall has 3 years of experience for that category. The programmer capability, rated high, assume programmers for this, same as the analyst capability, or analysts and programmers need to be in the 75th percentile, considering all those factors. The platform experience, rated that as nominal, assume 1 year of experience for the overall team. Programming language and tool experience, high, assuming 3 years of experience for the overall team. Now going into project attributes. The Modern programming practices, rated that as high, assuming general use of modern programming practices within the team. Use of software tools, nominal, using interactive debuggers and being a real-time operating system. Required development schedule, rated that as nominal, assuming no setbacks on the schedule as of this moment. Then the last attributes, like category. Require reusability, rated that as very low, assuming there will only be one system for the entire country as of right now, but maybe in later revisions, we can make like a smaller scaled, like one for each state, like that type of stuff. So we can have more storage and that type of stuff for the software. Documentation matched to life cycle needs, rated that as extra high. Since this can become safety critical software, if people trust the software and the user base is larger than nominal, this needs to be greater than nominal. So that's why we rated that as extra high. Personnel continuity, rated that as extra high, assuming that the personnel will not leave the company during this project. Multi-site development, rated that as very high since it's excuse me, since this system will be using the live feeds from people's social media, this would be national interactions. So that's why we rated this as very high. And based off these ratings and the total source lines of code, the COCOMO came up with a most likely result of approximately 58 person per month to complete this project. And the cost, the labor cost based on that would be about 512,000 for the whole length of the software. And with 5 project members, the project duration will be approximately 11.6 months. Then adding hardware and software will bring the total cost to approximately $517,100. And we'll get into the hardware and software costs coming up. So the hardware estimates, we're looking into desktop computers for each member, which would cost about a total of $3,000, router, which would be about $400, and workstation server, which would be about $1,700, which that's where the numbers come from, which get added on to the labor costs, which is a total of $517,100. So going into the risk management for this project plan, these are the categories of the risks that were agreed upon. So a performance risk. This risk concerns whether software will be will meet its requirements and fit for its intended use. So this is a really big thing, making sure that the software meets all the requirements that the customers and engineers agree upon. Then we have the financial risk concerning staying within the budget. Then we have so sorry about that. There was a little typo in the PowerPoint, but now it is fixed. And we will be continuing the presentation for the project plan. So discuss the financial risk and now the schedule risk. Excuse me. This risk concerns whether project schedule will be maintained and deadline met. So this is a very important aspect, making sure that we meet the project schedule, since one of the goals is to get it on this software on the market and being used within 2 years. So going into the top 5 risks for this project. The first 2 are the main ones that are worried about, and we'll be going into some risk plans for like plan out the mitigations and that type of stuff. But the first one, problems with the network. There's a 40% probability of occurrence, and the impact would be 4. So going into the impact values, 4 is catastrophic. Fatalities can occur. Other impact level is 3, critical. The system results will be off, but not life-threatening. Then 2, marginal. System still running, no major changes to the system. And 1, negligible. System running normal. So problems with the network would be an impact level of 4, which goes into a risk value of 1.6. So then we'll go into the risk management sheets later for the risks that score over 1.0 at the risk value, which the risk value is calculated from the probability of occurrence multiplied by the impact. And that's how those numbers are have been come up with. The other risks include problems analyzing the data. So we put a probability of occurrence of 40%, and that impact would be 4. So these impacts are rated 4 because if the software isn't working and people are relying on it to be working to get first responders over to them, then that's why these are impact levels of 4, because people may die. And this software may be to blame if it's not working because of these problems. So other risks that were less than 1, so there will be no risk management sheets for them, include problems importing data, problems sending data out to first responders database, and problems filing the data. So that one was categorized as an impact value of 3 because even though the filing will be off, it will still be sent over to the first responders. So as saying 3 is critical, system results will be off, but not life-threatening. So going into the risk management sheets. So going over the first risk, which was problems with network. Description: no problems with the cellular network will be critical for this CMS software to work and help first responders. So some subconditions, so some things that may happen, like some of the risks that might happen and this may occur, include cellular network stations are down, or natural disaster causes cellular outage. So this is where mitigating the problem, the software will connect to multiple cellular networks. So hopefully this will help mitigate. So if one cellular network is down, we can still get social media reports from other cellular networks. And some other contingency plan is having cellular network engineers on standby to fix the cellular network ASAP after it goes down and get it up and running just in case all cellular networks go down. Then our software will not have any social media reports. The second risk, which was the problems analyzing data. So this kind of description is analyzing the social media reports that are imported to the software will be critical in determining if the events that are happening are life-threatening and if first responders are needed. So some things that may happen, they're like predicting some risks that may happen, mislabeling a life-threatening event as not life-threatening, or vice versa, mislabeling a not life-threatening event as life-threatening. Those can be very like big issues when it comes to it. If those happen, then the first responders will think that they'll think the opposite. So they'll go to a location and it's not even a life-threatening event, and they'll have wasted their time there. So some mitigations, analyzing many historical, so past life-threatening event photos to make sure every case is considered in the software. Another one is using a similarity photo software to compare the past photos to the social media reports, so the present photos and videos, and make sure it is 75% or higher similarity with past life-threatening photos. So making sure it is like a fire or it is like a natural disaster, and that's what this software is doing, will be photo analyzing pretty much and making sure that it is like categorized correctly. And the third mitigation is testing. Testing will help make sure this problem does not happen. So there will be many days of testing and making sure that the photo software is categorizing these events correctly. And some management type stuff, if there are reports that our software is mislabeling events and it is causing lives to be lost, immediately take down the software and analyze and fix the problems before putting it back on the market and being used again. So the project schedule for our project, this is kind of a big overview of the tasks and what will be done and how much time is allocated for each. So the first task would be the customer meeting for the requirements. So getting the requirements laid out with the customer and being agreed upon. This will take 1 day. And the next is requirements development. So getting the requirements done. Excuse me. So requirements development. So developing the requirements and the constraints and making sure that this software, it will be satisfactory for the customer. Next task, receiving and storing data, programming. So getting the social media reports and storing that in our software. Next task, analyzing data, also programming. So analyzing, doing the photo software comparison in there. And then filing data, programming also. So making sure that it's in the right folder, either critical or non-critical event. And then another task, transmitting the data to the first responders, also programming, so sending it out to their data center. Then the next task would be testing and updating the software based on the errors in the testing. So those will run simultaneously and will be running together. And then the software integration. So integrating the software for it to go onto the market. So then the durations were made accordingly. Obviously going to give more testing for analyzing data and the more days for the analyzing data and the testing and updating the software, because those will be the big parts, making sure that the photo recognition and comparing the photos will be there won't be many risks once this software is put out. And that is the project plan for this crisis management system.